Welcome scholars, welcome back to the channel. This morning we're going to be looking at sequences and in particular the arithmetic sequence. What is a sequence and what is an arithmetic sequence? Well, a sequence is a list or a set of numbers or terms that obey a particular pattern, right? So they're either ascending or descending. They're obeying a particular law. So maybe you keep adding something to each one to get the next, or you keep subtracting something. So in terms of the arithmetic sequence, you're either adding or subtracting a common term to each of the terms to get the next term. So we say that there is a common difference. Right? In the arithmetic series, there's a common difference between the terms. And it's either, the terms are either ascending, keep getting bigger, or descending, keep getting smaller. I'm also going to be doing a video on the geometric sequence, as well as sequences that have combination of geometric and arithmetic patterns. So right now we're focusing on the arithmetic sequence. So we're going to try to figure out, look at the terms and try to figure out what are they adding by each time, or what are they subtracting each time. And once we have figured out the pattern, then we can just go ahead and fill in the missing terms. So you're either going to have two terms at the end that you're going to fill in to complete the sequence, or maybe you'll have some terms in the middle which might be just a little bit more difficult to figure out the pattern because they are in between, but we still can do it. So let's go together and see if we can figure out what's happening in the sequence, what is the pattern, what is the common difference, and then we can complete the sequence by filling in the missing terms. Alright, so definition in mathematics, a sequence is a set of numbers or terms that obey a particular pattern. In the arithmetic sequence, there's a common difference, right? So the common difference, which is often denoted by the letter D. So we are to write the next two terms or the missing terms of these sequences. Alright, so we have 3, 5, 7, 9. A good idea, what some students do is they actually write beside each one what is happening to that one to get the next. So from 3 to 5 we add 2, so we can put plus 2. 5 to 7 we add 2. 7 to 9 we add 2. So therefore the common difference is 2. The pattern that this sequence is obeying is that we keep adding 2 each time. So all we need to do then is to add 2 plus 9, which is 11, and then 2 plus 11, which is 13, and we have completed this sequence up to here. And any term which will come after that, we're just going to keep adding 2, because that is the pattern that this sequence is obeying. How about number 2? So from 0 to 1, we add 1. 1 to 2, we also add 1. 2 to 3, we also. So the pattern is we keep adding 1. The common difference is 1. So 3 plus 1 would be 4. 4 plus 1 would be 5. How about 16, 21, 26? What are we doing each time? So from 16 to 21, we add 5. 21 to 26, we also add 5. So we need to add 5 to 26, and that's going to give us 31. And we need to add 5 to 31, and that's going to give us 36. Alright, now this one is a little bit tricky because it has 2 missing terms. Alright, so we have 8, and then something is missing, and then 14, and then something is missing. Okay, so let's see, between the 8 and the 14, how would we get from the 8 to the 14? What would we add? So we would add 6, okay. And from 14 to the 20, we'd also have add 6. But remember, there's a missing term there, so that means we're going to need to divide those 6's into 2 because you need to spread it out between the missing term. So really then, we're actually adding 3. You see that? One term is missing and it represents, so that the space here would represent 2 of the common difference. And since the space is 6, so we're really adding 3. So 8 plus 3 would give 11, and 11 plus 3 would give 14. 14 plus 3 would give 17, and 17 plus 3 would give 20. So you see, we use that trick. Even though they gave us the ones in between, we could still figure out the common difference because a space was missing, so we just divided that space by 2 to account for the 2 common differences in between. Alright, here we have 2 terms missing again, one at this end, one at that end. So let's figure out what's happening in here. From 6 to 8, we add 2. And from 8 to 11, we add 3. So the pattern seems to be, we're adding different amounts each time. We've added, so we're adding 2 and then we add 3. So it seems like each time we're adding 1 more than the last time. So this time we need to add 4 then. So we added 2, then we added 3, now we need to add 4, so we would get 15, 11 plus 4. And this one would be, for this one, we would need to add 1 to get 6. So that means this one needs to be 5. So sometimes in the arithmetic sequence, they'll kind of twist things up on you. It's not always one common difference. It can be that you keep adding something to the difference each time, right? So you start out adding 1, then you add 2, then you add 3, then you add 4. So you have to look out for those kind of tricks. And don't fall prey to those tricks. Like I said now, sometimes it's ascending. So all of these were ascending. They were getting bigger. The terms were getting bigger each time. Some of them are going to be descending. So you're going to find that you keep subtracting something each time. So from 25 to 24, we subtracted 1. 24 to 23, we subtracted 1. So we're taking away 1 each time. That means this would be 22, and this would be...
Excuse me, ma'am.
Yes, ma'am.
When am I going to be able to read my story?
Pardon me?
You said after the math lesson, I'll be able to read my story.
Okay. Alright, so here we have 4.5, then 4, then 3.5. They're getting less, the numbers are getting smaller, we're subtracting something each time. What did we take from 4.5 to get 4? We subtracted 0.5, right? We subtracted 0.5. From 4 to 3.5, we also subtracted 0.5. So we need to take 0.5 from 3.5 and we would get 3. And if we took 0.5 from 3, we would get 2.5. 10, 7, 9, 6. From 10 to 7 to 9 to 6. Is it ascending or is it descending? Well, 10 to 7, that's descending. That's getting smaller. But then 7 to 9, that's ascending. 9 to 6, that's descending. This is another one of the tricks that are used in the arithmetic sequence. They're taking something and then they're adding something and then they're taking something, but that's a pattern. That's a pattern. So we need to figure out what are they taking and then what are they adding and then what are they taking and what are they adding. And we just continue that pattern. So 10 to 7, we take away 3. 7 to 9, we add 2. 9 to 6, we take away 3. So this is all we have to work with. So we can assume then that for each term they take away 3 and for the next term they add 2 and then they take away 3. So now we're supposed to add 2. So 6 plus 2 would give 8, and now we have to take away 3 from the 8 and that would give 5. Sometimes they twist it up on you, you have to look out. So it's not always the same common difference. It's not always just ascending or just descending. It can be fluctuating. Up, down, up, down, up, down. But the thing is, it follows a pattern. And once you can figure out that pattern, you will get the other terms. So just look and see. Maybe this time they're adding and then the number gets less. So that means they're taking something away. And they might be adding again and then taking away. So we just need to figure out. Alright, these numbers are getting less. They are getting less each time. 48, take away 8. So here we'll take away 8. That will give 40. I wonder if they keep taking away 8 though. Let's see if we keep taking away 8, if we would end up with 22. So sometimes it's just trial and error. If we take 8 from 40, we would get 32. And if we take 8 from 32, would we get 22? No, we wouldn't get 22. So it doesn't seem like they're taking the same thing each time, right? 40 take away 8 gives 40. Sorry, 48 take away 8 gives 40. 40 take away 8, 32. 32 take away 8 would give 24. So maybe they're taking, let's see if they take away 9. 40 take away 9 would give 31. Take away 10 would give 21. Take away 7 would give 33. Take away 6. Alright, so let's try if they're descending the common difference. Okay, so we take 8 from 48, we get 40. If we take 7 from 40, we get 33. If we take 6 from 33, we would get 27. And then if we take 5 from 27, we get 22. Alright, so at first we thought, okay, they're taking away 8, so maybe that's what they're doing all the time. But if we did that all the time, we would not end up with 22. Because 40 take away 8 would give 32, take away 8 would give 24, take away 8 would be 18, would be 16. So we would not end up with 22. So it's something else they were doing. So we tried to see, is the common difference getting less each time? So when we took away 8, we get 40. We took away 7, we got 33. Took away 6, we got 27. Took away 5, and we do end up with what they had, which was 22. So that's the pattern. Each time they take away 1 less than the time before. Alright, so these are getting less. 6.5. What are we subtracting from 6.5 to get 6 1/4. The difference between a half and a quarter is a quarter, so we're taking away a quarter. And from 6 1/4 to 6, we're also taking away a quarter. So, if we take a quarter from 6, 6 take away a quarter gives what? That would be 5 3/4. And 5 3/4 take away a quarter, that would give 5 1/2. Alright, so each time we're taking away, so don't think it's only whole numbers they can take away. They can take away decimals, as we saw in this one. They can take away fractions, right? 6 1/2, if we take a quarter out of that, we get 6 1/4. Take a quarter from that, we get 6. Take a quarter from 6, we get 5 3/4. Take a quarter from 5 3/4, we get 5 1/2. So look out for those. Look out for decimals. Look out for fractions. Look out for whole numbers. Look out for the pattern that is not a constant common difference, but they might be adding 1 each time to the common difference, or taking 1 each time from the common difference. So you have to look out for all of those. Alright, here we have a variable. We have x. So this is x. This is x plus 3. This is x plus 6. They're adding 3 each time. X plus 3 would give x plus 3. X plus 3 plus 3 would give x plus 6. So let's keep adding 3. So this would be x plus 9, and that would be x plus 12. 5, 7, 10, or from 5 to 7 we add 2. 7 to 10 we add 3. So the common difference is changing each time. It's getting more by 1. First we add 2, then we add 3. So now I think we must add 4. And then we add 5. 27, 27 and a half. So they're adding a half. So 27 and a half plus a half would give 28, and 28 and a half plus 28 plus a half would give 28 and a half, and that plus a half would give 29. So we ended up with what they have, so that's how we know we're correct. Alright, what are they doing here? 0, and then 0 again, and then 1, 3, 6. Well, they clearly aren't adding the same thing each time. So let's figure out what is happening with the common difference each time. From 0 to 0, we add 0. 0 to 1, we add 1. 1 to 3, we add 2. 3 to 6, we add 3. Alright, so each time they're adding 1 more to the common difference. So we add 0, we add 1, we add 2, we add 3. Now we must add 4, and then we add 5. So 6 plus 4, that's 10, and 10 plus 5, that's 15. Or the final one in the arithmetic sequence, 11 to 15. So that's, we add 4. I wonder if it's 4 we're adding each time. Let's try. 15 plus 4 would give 19. 19 plus 4 does give 23, and 23 plus 4 would give 27. So the common difference was constant each time for this one. Alright, so that's your arithmetic sequence. Remember, a sequence is just a list of terms, a list of numbers or variables that are obeying a particular rule, a particular pattern. For the arithmetic sequence, they're either adding something each time or subtracting something each time, and that thing that they're adding or subtracting we call the common difference. They can switch things up sometimes and make the common difference change for each term. So most times the common difference is constant. You keep adding 2, or you keep adding 3, or you keep subtracting 5, or you keep subtracting 10. Sometimes they're going to twist it up on you and they add 2, then they add 3, then they add 4, or they take away a half, then they take away a quarter. So you have to look. You just really have to look and figure out the pattern. Sometimes they'll want you to complete the sequence at the end. Sometimes they'll put missing terms at the beginning or in the middle. But you should be able to figure out the pattern. Sometimes you have to use trial and error. Just make sure you get back what they have, so you'll know that the pattern is legit. Alright, so in the next video we're going to look at the geometric sequence. If you have benefited from this video though, I would love it if you would drop a comment to say, "Thank you, miss." I would appreciate that. And I would also appreciate if you would share the video with others so they can benefit. And if you see the catalog, if you don't see the video you're looking for, just let me know in the comments and I'll do that video for you. So subscribe if you haven't subscribed before, and click the bell so you can be notified as soon as a new video comes up, which is quite often. You have to stay on top of things, right? These videos are coming out like a barrage, so you have to stay on top of things. Alright, my scholars, I'll see you in the next video.